All right, ladies and gentlemen, so today we're going to now start trying to pull together what we did at the very end of class yesterday, or today, depending on when you're watching this, about our linear relationships. And we're going to start with a review from last year with a proportional relationship. Okay, proportional relationships. Two variables have a proportional relationship if their respective values are always in the same ratio. The same ratio is always y over x, which we looked at yesterday when we did that graphing stuff. But anyway, let's see what we have going on here. At a local farm stand, 6 apples can be bought for $4. Determine how much it would cost to buy the following amounts of apples. Round to the nearest cent when necessary. So we know we always put money over, so we know for $4 I can get 6 apples. So that's the ratio, 4 over 6, which would reduce to 2 over 3. I want to know how much money would it be for 12 apples. And there's a bunch of ways that you can figure this out. You could, set up a proportion, we can cross multiply. You can look at these as equal fractions and try to do it that way. You can be like, okay, 6 times what gave me 12, so then 4 times whatever. So the idea, though, is that if I go from here to here, I'm multiplying by 2, so I should be able to spend $8. Some of you might just say, well, I doubled the number of apples, I have to double the amount of money. And that's okay, too. This is the same ratio, though. Now I want to know for 20 apples. So I'm going to have 4 over 6, and I want to know for 20 apples how much. Now, this one doesn't go in so nice and easy. So I'm going to do some cross multiplying to set up an equation. So I'm going to get 6x equals 80. I'm going to divide both sides by 6, which means that when I do my 80 divided by 6, 13, and it says round to the nearest cent, so it's $13.33 is what 20 apples is going to cost me. All right, if C is the total cost of the apples and N is the number of apples bought, write a proportional relationship between C and N. Solve the equation for C. Okay. We know then, I'm going to use this ratio up here. Okay, so I know that we have, this is money, and this was apples. But we're using C and N. So, what is that going to tell me? What do I have to do there? So I'm going to basically set this up as a general equation using what we know, and then I'm going to use what we did from chapter 1 to get our C by itself. So I know then, we're talking about money over apples. We know it's a ratio of 4 over 6. This is then going to give me, this is cost, this is number of apples. So if I do my cross multiplying from here, I'm going to have 6C equals 4N. And now I want to get C by itself, so I'm going to divide by 6. So C equals 4/6 N. Or I could rewrite that as 2/3 N and put it in the lowest terms. Graph the relationship below, and apparently there's no graph. Nope, no graph at all. If you were to put that in your calculators, I'm just going to kind of sketch a graph here, If I put this into my calculator, I'm going to have, I know it's going to go through the origin, and I just want you to kind of sketch it. So it's going through the origin, and it's going to kind of be, we know it's a vertical compression because it's a fraction, so it's not going to be straight up and down, but it's going to look like that. According to the graph, C of 15 equals 10. Illustrate this on your graph. How do you interpret C of 15 equals 10 in terms of apples and money spent? I don't know what that means. I'm sorry. So I'm assuming that means that for $10, for 15 apples. I'm not really sure. Sorry about that. Okay, moving on. Jenny can run 5 meters in 2 seconds. Which of the following gives the distance she can run over a span of t times? Remember we did this before, D equals RT, right? So we have to know what our R is, which is our unit rate for this. So we're going to have 5 meters in 2 seconds. So 5 over 2 is going to be R. So we have D equals 5 halves T, which is choice D. Erica is driving at a constant rate. She travels 120 miles in the span of 2 hours. If Erica travels at the same rate, how far will she travel in 3 hours? Well, you can do this one of 2 ways. To simplify things, I know if she's going 120 miles in 2 hours, she's going 60 miles in 1 hour, which means if she's traveling for 3 hours, I can do 60 times 3, 180 miles. Write a proportional relationship between the distance D that Erica will drive over the time T that she travels, assuming she continues at the same rate. So I don't even have to set it up as a proportion, but I will. So we're using, we know it's 60 miles in 1, so distance over time. So when I cross multiply, we're going to have D equals 60T. If I had put in the 120 in the 2 hours, you would still get the same thing. What is the value of the proportionality constant? 60. What are units? Miles per hour. How much time will it take for Erica to travel 150 miles? So I could now use that equation, right? We have 150 is my distance, 60t divided by 60, and you should get an answer of 150 divided by 60. You should get an answer of 2.5 hours, or t. Graph D is a function of t on the axis at the right. So we know after 1 hour we've gone 60, and these are going up by 2, so by 20s I should say. So 20, 40, 60. 2 hours she was at 120. So there's your graph. How does the constant of proportionality, what does the constant of proportionality represent about this graph? Well, it represents that she's going 60 miles per hour. Characteristics of a proportional graph: it is a straight line through the origin. And we did all of that last year. All right, I'm sorry for the pauses and so on, because it's last minute. I promise the other ones will get better. But if you have questions, bring them to class, and have a good night.